This is section 4.3. In this section, our goal here is to be able to solve quadratic equations where our a value here is equal to 1. A little bit of vocab. A monomial is an expression that is either a number, a variable, or the product of a number and one or more variables with whole number exponents. So a monomial could be a number such as just regular old 6, or it could be a variable like x, or the product of a number and a variable. So that could be like 7y. That is a monomial. A binomial, on the other hand, think bicycle like 2. That means the sum of two monomials. So it could be like 8 plus z. That is a binomial. And then a trinomial, think tricycle with 3 wheels. That's the sum of 3 monomials. And notice it's sum. So that could look like x squared minus 4x plus 9. That is a trinomial. So we have this quadratic equation that we're trying to solve for x. One way of solving for x is by factoring. So when we go to do this, we're going to find the values that multiply together to get the c value and add together to get the b value. So if the equation is in the form x squared plus bx plus c equals 0, then both signs are positive in the end. If the equation is in the form x squared minus bx plus c equals 0, both signs are negative in my factors. And if the equation is in the form of x squared plus bx minus c equals 0, or x squared minus bx minus c equals 0, one sign is going to be positive and one sign is going to be negative inside our factors. So this first example, we're going to factor x squared minus 9x plus 20. With these, I always start out with a x. Okay, so I'm going to use the x method to factor. So with my x method, what I put up top always is multiplying my a and my c together. So if I take 1 times 20 in this case, that's 20. And I'm going to stick that up top. Then I'm going to take my b value and put it in the bottom. So in this case, that's negative 9. So I'm going to pull 20 out to the side for a second because that was the number on top of my x. And I'm going to think it factors of 20. So I know 1 and 20, 2 and 10, 4 and 5. And I just stop until I run out or I see a pair that can somehow make a negative 9. Okay. Well, this pair right here can help me get to a 9 somehow. But in order to make it a negative 9, I'm going to use both of them as negatives. Okay, so negative 4, and if I add negative 5, it makes negative 9. But if I multiply these two, it makes it positive 20. And last but not least, since my a value was 1, I'm going to put a 1 on top and attach an x to it, because I had 2 x's to begin with. So my factors for this are going to be x minus 4, that's my first one here, and then x minus 5. Okay, so here's my factors, or I factored that expression. To check yourself, you can always go back through and do FOIL again. So if I use FOIL on those two factors, that would get me x squared minus 5x minus 4x plus 20. And if I simplify those two x terms in the middle, that gives me negative 9x plus 20, which was the same expression that I factored to begin with. See, that's kind of like a mental check you could do to see if you factored that expression the right way. If I try to do this one, I'm going to again use the x method. So this time, my 1 is out front here, and I'm multiplying 1 times negative 12, well that's negative 12, so I'm going to stick that up top here. Then my b value is 3, so I'm going to stick that in the bottom. So I'm looking for factors of 12. So I know 1 and 12, 2 and 6, and 3 and 4. And I'm picking out a pair that could somehow make a 3 for me. But as I go down through these pairs, well, none of them help me make 3. None of them add to 3, but multiply the negative 12 as well. Okay, since that's not working out, this one cannot be factored. And that's my answer, because it just simply can't be done. So it can have the case where it cannot be factored. So that is the simplest expression it could be, is x squared plus 3x minus 12. So we have, with factoring, a couple of special factoring patterns. We have the first one, that is a difference of two squares. Difference meaning a subtraction of two perfect squares. So what that means is I have one square and I'm subtracting another one from it. And when this happens, I have one positive factor and one negative factor. So for example, I have here x squared, which is a perfect square all on its own. And we're subtracting out 4. Well, that's a perfect square too, because 2 squared is 4. So in the end, my factor is x minus 2 and an x plus 2. Also, we have perfect square trinomials. So if I have a perfect square for a and b, and I see a product of a and b times 2, or it's doubled, then that can also be a perfect square, and it will be, or it will have a plus sign in the middle of those two factors. So it'll look like a plus b times itself again, which is the same thing as a plus b squared. So for example, here I have x squared, and then I have a 2 times x times 3, and then I have a 3 squared. So I'm taking x and 3 and 2 and doubling it in the middle, and I have a 3 squared on the end. So my factors here for it will be x plus 3, because that's what I'm using at the beginning and at the end, kind of like what we did up here, the beginning and the end. So that was x minus 2, x plus 2. But this one is strictly x plus 3, since my 3 was positive here. Same thing down below. If I had the difference and then a subtraction here, then I'm going to use the minus sign with that. So like for example here, x squared, and I have a 2 squared here, but in the middle they subtracted 2 times x times 2 and then added that in the end. So it doubled those in the middle to make a negative 4x. And then in the end, that would make an x minus 2 and an x minus 2, which is the same thing as this x minus 2 squared. So let's use these properties or special patterns here. So if I factor this expression right off the bat, I see two perfect squares. I see x here, and 49 is a perfect square of 7. So if I put these together, this is a difference of squares. So one factor is x plus 7, and the other one is x minus 7. And that is it. And again, I could check myself with FOIL. Okay, so that'd be x squared if I use FOIL, plus 7x minus 7x minus 49. Well, these in the middle go away, and I'm left with x squared minus 49, which is originally what I had to factor to begin with. So that one checks out. In example 2b, I see some perfect squares going on. I know x is a perfect square there, and 169 is actually a perfect square of 13. And if I look in the middle here, if I double x and 13, that does make a negative 26 here. So this is a perfect square trinomial, which in the end will help me make an x minus 13 and an x minus 13. And again, those are coming from these right here. Okay, so x minus 13s. And since I have two of these, in the end, I could just simplify this to x minus 13 squared. And here we go. So here I have 1 set equal to 0, but we're still going to do the same exact thing. So if I'm going to multiply my 1 and my negative 36 together, I got negative 36. And that's on top of my x. So I'm putting in below my b, which is negative 5. And I'm pulling out to the side my factors of 36. So I know 1 and 36, 2 and 18, and then 4 and 9. But I can immediately stop because 4 and 9 can help me make a negative 5 if I use 4 minus 9. That added together makes negative 5. And also if you multiply 4 and negative 9 together, you get negative 36. Then on top, my a was 1, so I'm putting a 1 on top and attaching an x to it. So here are my factors here, x plus 4 since 4 was positive, and x minus 9 since 9 was negative. And it's still set equal to 0. So what I'm going to do with that is I'm going to split these apart. So since it's equal to 0, I'm going to split them apart and set each one individually to 0 and solve for x. Well, if I subtract 4 here, I got negative 4. And if I add 9 here, I get back 9. So here's the two solutions to that quadratic equation. If I plug in negative 4 or 9, I can get back 0 in the end. So this is what we call finding roots or zeros of a quadratic equation or function. So we're still doing with quadratics that look like ax squared plus bx plus c. And since it's an equation, it's going to be set equal to 0. Okay? The roots of an equation are just the solutions of a quadratic equation. So whatever x equals is called a root. But roots and zeros are the same exact thing. Zeros are the value of a variable that allows a function to equal 0. These are also called x-intercepts. So make sure you have that in your notes as well. So you might hear them called roots, x-intercepts, or zeros. What that means is if I have a graph here, and I have my parabola shape on here somewhere, okay, where they cross the x-axis, in this case here and here, that are in blue here, that's my zeros, or my roots, or my x-intercepts. It's where they're crossing the x-axis. So in this example, we're going to find the zeros of the function by rewriting it in intercept form. So basically what we're going to do is rewrite it in intercept form by factoring it. So again, I know here's a 1, and I'm going to multiply these two to make negative 12. So my x is starting out with negative 12 up top. But my b in this case is negative 1. So if I pull 12 out to the side, I know 1 and 12 multiply to make 12, 2 and 6, and 3 and 4. But this pair can help me make negative 1. If I do 3 minus 4, that makes negative 1. Same thing, 3 times negative 4 gets me back to negative 12 if I multiply them. Then on top, since my a was 1, I'm putting 1 up there and attaching 1x. So here are my factors. X plus 3 since 3 was positive, and x minus 4 since 4 was negative. But I'm going to set it equal to 0 because we're trying to find the zeros of that function. Which again just means just simply splitting them apart and solving for x after we set them both equal to 0 individually. So if I subtract 3 here, well, x is negative 3. And if I add 4 here, x is equal to 4. Okay, so my zeros in this case, if I put them as points, that's negative 3, 0, and 4, 0. So if they ask for zeros, make sure they are in point form here. So there are my zeros for that quadratic equation. They are crossing the x-axis at negative 3, 0, and 4, 0. And we have one more here. So if I do this one, I need 1 times 36 is 36. So I'm starting out my x with a 36. And I'm putting my b down there. In this case, it's 12. So I'm trying to make a chart of factors for 36. But I know 1 times 36 is 36. And again, 2 and 18. 4, 9. 3 and 12. And 6 and 6. But as I look through there, I'm picking out a pair that add to 12, which 6 and 6 do. And when you multiply 6 and 6, they do make 36 again. And I'm putting a 1 up there because my a was 1, and I'm attaching an x. So since they are the same thing, I do need to write them out twice. So x plus 6 and x plus 6. And again, since I want zeros, set that equal to 0. Now I need to split and solve it. So x plus 6 equals 0 and x plus 6 equals 0. And since they're both the same thing, I only need to do one of them. So 0 minus 6 is negative 6. So my only 0 in this case is negative 6, 0. Okay, and what that means is if I have my little sketch of my graph here, okay, that means my parabola is only hitting the x-axis at negative 6, 0, or in one place. So it's looking like this. It's barely touching it in one point. So my vertex there will be negative 6, 0 to draw my parabola on my coordinate grid.